So graphing trig functions is just like graphing any xy function. The difference is that our x-axis is going to be some angle or series of angles we choose, and the y-axis is going to be that trig function, the coordinate of that trig function evaluated at that angle. So here I have this smooth continuous graph of cosine. I can see here that when the angle is pi, the output I get is -1. Well, if I go to my unit circle and I look at my x-axis for cosine, at pi here, my x-axis is -1, so it correlates between the two. Pi here is -1, pi here is also -1, so they're both the same thing. The difference is we have an xy coordinate this time. So some things to note before we look at some examples. My 5 quarter points for reference go from 0 to 2 pi, the full unit circle. And my y output is simply that trig function evaluated at these various points. So for example, cosine of 0 is 1, and cosine of pi over 2 is 0, etc. These points are going to be referenced anytime we make a change to the function. This is the general structure of a trig function, but the main takeaway is that the period is 2 pi over b, where this is right here is b, and phase change is c over b, c and b. This will all make sense once we do the first example. So here I have the function y is equal to 3 cosine 2x plus 2. The first thing I'm going to do is look at my b and c values. B is 2 because that's what's in front of the x, and c is 0 because there's nothing attached here, right? So my phase change is 0 because 0 divided by 2 is still 0, but my new period on the other hand, right, is 2b over b, or simply 2 pi over 2, and I get just pi. This means that my new interval, instead of going from 0 to 2 pi, I'm going to go from 0 to pi. And that's what I put right here. Now to get my points in between, right, 0 to pi, my new interval, I'm going to subtract this upper bound minus lower bound and divide by 4. That's going to give me my increment, which means that I'm going to start at 0 and I can count by quarters until I get to pi. Those are going to lead me to my new theta values right here, the ones I'm going to plug in and evaluate. Now, the next part is just evaluating your y outputs. I have a 3 and a 2 here. Just think back to your PEMDAS. I'm going to use this coefficient 3 times the y, and then I'm going to add 2. It's multiplication first, then add. So the first point, it's going to be 3 plus 2, it's going to be 5. And I can do that for the rest of these points here. And just like that, I have an x, y coordinate. You can plot these on the graph. It's very simple. 0, 5, pi over 4, 2. You get the idea. One more example. This one's much trickier, but if you can get this one, you'll be set. So, b is equal to 2 pi, and c is equal to -4 pi, because I'm adding here, which is the opposite of subtracting over here. I'm going to look at my phase change is -2, but I'm also going to look at my new period, which is 1, because 2 pi divided by 2 pi is 1. Now this tells me that I'm going to start my interval at -2, start there, and to get my upper bound, I'm going to simply add -2 plus 1. It's going to get me -1. So that's my new interval. I'm going to go from -2 to -1. To get my points in between, or my increments, I'm going to subtract -1 minus -2 divided by 4. That's how much I'm going to count by. So my new x values are going to be -2, because that's where I started with, then add a quarter, and add a quarter, and add another quarter until I get back to -1. 1, 2, 3, 4, 5, because it's the same as 1, 2, 3, 4, 5 quarter points. Now, I know that was a lot, but the final part is easy. I don't have a plus anything here, so I'm going to strictly multiply my y values by -3. That's going to give me my corresponding y values. So -2, comma, -3 is my first point, etc.